Hey guys, hoping all is well with everyone. Today we're going to be looking at our question of the day, and we're going to be asked to factor by grouping the expression 2x squared plus 3x minus 2. So before I jump into this, if we weren't restricted to just factoring by grouping, I want to remind you guys that the quadratic formula is always the ace in your pocket. As intimidating and daunting as it can be, it's the one surefire way to be able to find the solutions to a quadratic, despite of what it is. Remember, you can also use your discriminant approach to determine how many solutions your quadratic will also have. But in the end, the quadratic formula is like the ace in your pocket, and a last resort to when you're really having trouble figuring out the greatest or most ideal method of factoring to use. So when it comes to factoring by grouping, with this expression 2x squared plus 3x minus 2, there's an elephant in the room that we kind of have to get out of the way first. With factoring by grouping, you have to have a four-termed polynomial, and in this case we have a trinomial. So you're probably wondering, how do I get around that? Well, what you can do is represent this trinomial as a four-termed polynomial, but in a way that doesn't change the algebraic value or expression. And what I mean by that is what we're going to do is we're going to re-represent or display the linear term and break it into a sum of two linear terms that add up or subtract to 3x. Now this takes a little bit of practice, and you're going to see going forward in these steps why. But I'm going to be typing out the steps as we go. So step 1 is going to be reconfiguring the representation of the trinomial into a four-term polynomial. So the way I'm going to do it for this one is I'm going to say that 2x squared plus 3x minus 2 will now be represented as 2x squared plus 4x minus 1x minus 2. So that already solves the biggest problem and challenge that we got right from the get-go, is we can't even factor this guy because it's represented in a way that we can't group anything yet. But now we can, because if I combine the like terms of 4x minus 1x, I get my original 3x that I started with. But I need this to be a four-term polynomial. So after step 1, problem solved, and now we can continue with our method. So when we're factoring by grouping, what we're essentially doing is we're taking this four-term polynomial and breaking it up into two bracketed pairs of binomials. And what that allows us to do is focus on the greatest common factors of each of those binomials, and then our ultimate goal is to find the common factor that the two bracketed binomials share. So that was quite a lot in one step, but for step number 2 is very simple, and it's just bracketing the four individual terms into two pairs of binomials. Now I will also mention that in this step where I did plus 4x minus 1x, it does not matter if you would do negative 1x plus 4x. It all still will work out. So I'm going to go ahead and create my brackets, and I'm going to go ahead and kind of bracket off the four individuals into two pairs of binomials. Now what's really important here is to also contain the signage on each of your terms. That can cause a lot of students some simple mistakes and points off because they end up having sign errors, which gets, again, very simple mistakes, but it will reduce points. So in this case, I'm kind of referring to the -1 on the x linear term. -2. Alright, so that's step number 2. Step number 3 is going to be using the greatest common factor method in each of these two binomial pairings to find the greatest common factor between them. But also keep in mind that as we do this, our ultimate goal is to also find the common factor both of these binomials share. So step number 3, use greatest common factor method to factor first binomial. So to do that, we're going to take the binomial 2x plus 4. We're going to 2x squared plus 4x. And we're going to go ahead and factor this. So remember, factoring is like division. It's the inverse of the distributive property. So whatever I factor out, I am going to take that factor out of the original term and decipher what its remaining term is. So the greatest common factor that exists between 2x squared plus 4x is going to be 2x. I always tell my students to do the coefficient part first and determine that greatest common factor, then do the variables. It breaks things down and makes housekeeping a lot better. So this is going to be the factored form. If I factor out a 2x from 2x squared, all that I have left is the x. And then if I factor out 2x from 4x, all I have is a factor of 2 left. Okay. Now, this x plus 2 is a very important factor because it is the common factor that these two binomials are going to end up having in common. So I want to keep that in my head as I go to the next step, because my next step is to factor the second bracketed binomial in a way that allows me to, once I factor out a greatest common factor, gives me that common factor of x plus 2. So step 4, step 4 is going to be factor the second binomial with the remaining factor being the remaining factor of the first factored binomial. In essence, what that means is, after I factor out the greatest common factor of negative 1x minus 2, my remaining factor will be x plus 2. Now, you're probably going to notice, if you look very carefully, is that the only difference that negative 1x minus 2 and x plus 2 have in common is that there's a sign change on them. So what we can do here is what's called forcing a sign change. So a sign change is always what's going to occur what happens when you divide or multiply by negative numbers or distribute negative numbers. So what I mean by that is, if we look at negative 1x minus 2, if I factor out a negative 1 as a greatest common factor, I'm going to force a sign change on each of these terms of negative 1x and negative 2, causing it to become positive x plus 2. And that is the equivalent or the same as our remaining factor that we got from the first binomial we factored, and that's what our goal is. It was to find the common factor that they share. So now what we're going to do is we're going to create the factored forms of this expression by having our common factor, which is x plus 2, and then the other factor is going to be the linkage or the sum or difference of the greatest common factors that those two binomials have. So we're going to have x plus 2, which is the common factor, and then the other one is going to be the greatest common factor of the first binomial, and then you have the greatest common factor of the second binomial. So your factored form of 2x squared plus 3x minus 2 is going to be 2x minus 1 times x plus 2. Now, I always like to make it a habit to check your answers in any type of math problem that I can possible. So step 5 is going to be to check your factoring. And you're going to do that by using the FOIL method. So let's go ahead and do that. If I factor out, if I FOIL out these two binomials, I should get my original 4-term polynomial that I started with after I re-represented the trinomial. So let's go ahead and do that. So if I take x minus 1, x plus 2. So remember, FOIL is first, outer, inner, last. We'll go ahead and do the acronym. So I have first is going to be 2x times x. That's going to be 2x squared. O stands for outer terms, so that's going to be the 2x times 2, which is 4x. I is going to stand for inner, so the inner term is negative 1 times x, which is negative x or negative 1x. Remember that 1 can always just be used for housekeeping. In a lot of tests and standardized tests, you won't see it on a variable, again, that is a non-zero variable, or if it's just a inferred 1 coefficient on x, you won't see it, but again, it always helps for housekeeping and just keeping things organized. And then the last is going to be negative 1 times positive 2, which is negative 2. So now you see that I have the terms from my original post step 1. So now I have 2x squared plus 4x minus 1x minus 2, and then my final step with checking my answer will just be to combine the like terms, which gives me 2x squared plus 3x minus 2. Okay, so that does indeed check from my original trinomial I started with. I hope this helps you guys out, and as I mentioned, if you ever are looking for any requests of the step-by-step approaches or methods to any math problems, I do questions of the day as often as I can, and if you have any certain requests on just a walkthrough, please don't hesitate to comment or message. But I hope this helps you guys out, and as always, please take good care of yourselves and be safe, and we look forward to seeing you soon. Bye.